Now let's expand our understanding of triangles and trigonometry into some unit circle trigonometry. And so this is all based off of angles inscribed inside of circles. And so let's imagine for a moment that we have a circle. Let's see how good of a circle I can draw. There we go, perfect. We have a circle and we can draw an angle inside this circle. And let's say this circle, this angle rotates some amount of degrees. Let's say, just to keep it simple, let's say a rotation of 30 degrees. So we have this angle that rotates 30 degrees within the circle. Well, if we were to keep rotating all the way around until we get back to where we started, that would be a full rotation of 360 degrees. The measures of degrees in the arc of a full circle is 360 degrees. Now, the other way that we can measure degrees or an angle rotation is radians. And what radians is we are creating this arc length here. We are creating this arc when we rotate an angle. And so that arc is referred to as the radian measure, the radian length. So when we're creating that arc length, the size of that arc is going to depend on two things. So it's going to depend on the amount of the rotation, but will also depend on the length of the radius. And so one rotation of radian, 1 radian is equal to 1 radius of our circle. 1 radian is equal to 1 radius. And as we go all the way around, we actually have a rotation of 2 pi radians. If we go all the way around our circle, it is a rotation of 2 pi radians. If you think back to your geometry days, when you're learning about circles and the formulas circumference and area, our circumference formula utilizes that fact that the distance around is 2 pi radians, and 1 radian is equal to 1 radius. 2 pi times the radius. And so full rotation is 2 pi radians. And so those are the two kind of measures that we use. Angle measures in degrees is a little bit more intuitive for most of us. It's a lot more familiar understanding. But also in trigonometry, we often use radians, and several of our formulas utilize radians when we're considering ourselves with measuring the length of an arc. And so we need to be comfortable going back and forth between the two. So since there's this relationship where 2 pi radians is a full rotation, and 360 degrees is a full rotation, well, those two values have to represent the same thing, therefore they're equivalent. And so we can write a ratio or a proportion using this information, 2 pi radians over 360 degrees, or 360 degrees over 2 pi radians. This gives us a ratio that we can use to convert from radians to degrees and degrees to radians. And we can also simplify this fraction if we divide the top and the bottom by 2 to get pi over 180 or 180 over pi. So let's take a look at how we can use these in order to evaluate or to convert from degrees to radians or back. So here we want to convert 90 degrees into radians. And so we're going to start with 90 degrees, and we want to think about when we're doing unit conversion, we want the degrees unit to cancel out. If we multiply by pi radians over 180 degrees, well, that gives us the result that we want. My degrees units eliminate, leaving me with 90 pi radians divided by 180, and then we can simplify our fraction. 90 divided by 180 is pi over 2 radians. We could also write this as 1/2 pi radians. And we're going to utilize that fact in the next question. The number of radians in a 135 degree angle can be written as A times pi. So we're looking for this value when we convert to radians. So let's take a look. 135 degrees times pi over 180, and that's going to equal 135 pi radians over 180. The degrees units cancel, and we're left with just radians. And then we can go ahead and simplify, and that reduces to 3/4 pi radians. And so we're looking for the value of A, so A equals 3/4. Now, if we want to convert our radians back into degrees, we can do that here. And so we know that 135 equals 3/4 pi, so we should be able to get back to 135. So we know that 3 pi over 4 radians. This time we want to eliminate the radians unit measure. So we want pi radians to be in the denominator with 180 degrees in the numerator. That allows radians to cancel. And in this case, but not all cases, pi also eliminates, leaving us with 3 times 180 degrees divided by 4. And when we simplify and evaluate it, we do indeed get back to 135 degrees.